Dear students, myself Dr. Mallikarjun S. Biradar, Assistant Professor in Mathematics, Government First Grade College, Baswa Kalyan. So now, today's session, the 40th session of Graph Theory 2. The title of the topic is Critical and K-Critical Graphs. Okay, so this is the title of the topic. Let us see what is a critical graph and what is a K-critical graph. A graph G is called critical if the chromatic number of H, where H is a subgraph of the graph G. So if the chromatic number of the subgraph is less than the chromatic number of the graph, it is for every proper subgraph H of G. Suppose G is a graph, and if you consider any proper subgraph of G, okay, for that subgraph, if you find the chromatic number of H should be always less than the chromatic number of the graph. It is for every proper subgraph H of G. Then that graph G is called a critical graph. So once again, a graph G is called critical if the chromatic number of the subgraph is always less than the chromatic number of the graph for every proper subgraph H of G. Okay, so this is about the critical graph. Then what is the definition for a K-critical graph? A K-chromatic graph is called K-critical. K-chromatic graph. What do you mean by K-chromatic graph? A graph is said to be K-chromatic if its chromatic number is K. Okay, so a K-chromatic graph is called K-critical if it is critical. Don't get confused. A K-chromatic graph is called K-critical if it is critical. Means again it is a graph G whose chromatic number is K, and whenever it is chromatic number is K, it is called K-critical graph. Again, if you consider any proper subgraph of this graph, again the chromatic number of the subgraph must be always less than the chromatic number of the graph G. Then you can say it is a K-chromatic graph. Okay, so a K-chromatic graph is called K-critical if it is critical. So obviously every K-chromatic graph has a K-critical subgraph. It's very obvious. It's very obvious that every K-chromatic graph has a K-critical subgraph. Okay. Now we will consider one interesting result on this statement. What is the statement of the theorem? If G is a K-critical graph, so what do you mean by K-critical graph? A K-chromatic graph is called a K-critical graph. Okay, whenever it is K-chromatic, it is called K-critical if it is critical. So that is very important. A K-chromatic graph is called K-critical if it is a critical graph. What do you mean by critical graph? If you consider any proper subgraph of the graph G, the chromatic number of the subgraph of this G must be less than the chromatic number of the graph G. Okay, then it is called a critical graph. So if G is a K-critical, then delta G is always greater than or equal to K minus 1. So where delta G is the minimum degree of the graph. Suppose minimum degree and maximum degree. We know amongst all the vertices, which vertex has the least degree, that is the minimum degree of the graph. Amongst all the vertices, which vertex has maximum degree, that would be the maximum degree of the graph. Okay, if I consider K3, so the degree of every vertex in K3 is 2 because it is a complete graph with 4 vertices. So every pair of its vertices are adjacent. So it is 2. So therefore, what you can say, degree of every vertex is 2. Okay. Similarly, if you consider C5, so C5, say it's a cycle with 5 vertices, then the degree of every vertex is 2. So maximum is also 2, minimum is also 2. So there you can say the maximum degree and minimum degree are equal. Okay. So therefore, if you consider K23, so 2 vertices at the top and 3 vertices at the bottom. or you can say those two vertices are in one set, the other three vertices are in the other set. But complete bipartite graph means each vertex of one set is adjacent with every vertex of the other set. It implies degree of a vertex in one set is 3. In the set V1 is 3, 3, 3. But the degree of the vertex in the other set V2 is 2 only. Okay, so there you can say the maximum degree is 3 and the minimum degree is 2. Okay, so this is the clarification about the minimum degree and maximum degree. These are the basic ideas already we have discussed in the previous semester. Okay, what is the degree of a graph and what is the minimum degree, maximum degree. Now the result is, if G is a K critical, then the minimum degree of the graph is always greater than or equal to K minus 1. So this is the result. Now how to prove the result? Suppose G is a K critical graph. Suppose G is a K critical. Then for every vertex V of G, what is the chromatic number of G minus V, which is equal to K minus 1. So once again, so here there is a confusion. I should consider small vertex V. What is that? We have considered a graph G which is K critical. It implies it is a K chromatic graph. Then we have considered one arbitrary vertex V. If I delete that vertex from the graph, then what is the chromatic number? The chromatic number will be reduced by 1. So earlier it was K, now it will be K minus 1. It implies degree of that vertex is less than K minus 1. Then a K minus 1 coloring of G minus V can be extended to a coloring or extended to a K minus 1 coloring of the graph G by assigning to V a color which is assigned to none of its adjacent vertices in G. So thus what we can say, degree of V is greater than or equal to K minus 1. Therefore the minimum degree of G is always greater than or equal to K minus 1 because V is an arbitrary vertex. So this is how we have proved the result. Let us consider another theorem. For any graph G, you can consider any graph G. The chromatic number of that graph, any graph G, is always less than or equal to delta G. There also delta G, here also delta G, but the difference is here it is maximum degree of the graph plus 1. So the chromatic number of any graph is always less than or equal to delta G plus 1, or you can say it is an upper bound for the chromatic number of a graph. So therefore to prove this result, first we consider, let xi of G be the chromatic number of G. Okay, let H be a xi of G critical subgraph of G. H is one subgraph which is xi of G critical subgraph of G. Okay, it is a subgraph of the critical subgraph of the graph G. By one of the theorem, what we can say by using the previous theorem, minimum degree of the subgraph H is always greater than or equal to the chromatic number of the graph G minus 1. This is by the previous theorem. Hence, the chromatic number of the graph G is always less than or equal to the minimum degree of the graph H plus 1. So it is known that the minimum degree of the graph H is always less than or equal to the maximum degree of the graph, and hence we conclude the chromatic number of the graph is always less than or equal to the maximum degree of the graph plus 1. So this is the proof for the theorem. Okay, let us consider some example based on these results. So give two different graphs such that each satisfies the xi of G, that is the chromatic number of G is equal to maximum degree of the graph plus 1. So we need to give two different graphs such that the chromatic number of that graph should be maximum degree of the graph plus 1. Okay, so for example, let us consider G equal to Kp, a complete graph with p vertices. Then what is the chromatic number of this graph? Already we know the chromatic number of the complete graph Kp, the chromatic number of the familiar graphs. In that session already we have discussed. So complete graph means every pair of its vertices are adjacent. So therefore, to color a complete graph with p vertices, we need p colors. So therefore, the chromatic number of Kp is always p. So that's why it is p. And what is the maximum degree of the graph? In a complete graph, it is a regular graph, of course. In a complete graph, degree of every vertex is same. If it is Kp, then it is p minus 1 regular. It is p minus 1 regular. It implies degree of every vertex in Kp is p minus 1. It implies degree of every vertex is same, that is p minus 1. Maximum degree, or you can say minimum degree. Both are one and the same. So therefore, the maximum degree of the graph is p minus 1. Then the chromatic number of Kp is equal to p. As already we said, the chromatic number of the Kp is definitely p. But this p you can rewrite by adding and subtracting 1. What happens? It will be p minus 1 plus 1. But what is p minus 1? P minus 1 is the maximum degree of Kp plus 1, isn't it? So this is how we have proved the chromatic number of Kp is the maximum degree of Kp plus 1. So this is one example which satisfies the condition. Let us consider another example, G equal to Cp. It is a cycle with p vertices where p is greater than or equal to 3. Suppose if it is odd, what happens? Then the chromatic number of a cycle with odd number of vertices is 3. That already we know. If it is a cycle with even number of vertices, it is 2. But if it is a cycle with odd number of vertices, or you can say odd length, definitely the chromatic number is 3. Okay. And what is the maximum degree of a cycle? Again, cycle is a 2 regular graph. Degree of every vertex in a cycle is 2, 2, 2. Every vertex is of degree 2 because you can see the cycle, the structure of the cycle. So it is a 2 regular graph. It implies again maximum degree, or you can say minimum degree. Both are one and the same. It is 2. So therefore, the chromatic number of Cp, it is 3, which is equal to, you can write it as 2 plus 1. So but 2 is the maximum degree of the cycle Cp plus 1. So these are the two examples which satisfies this condition. Chromatic number of G is equal to delta G plus 1. That is the maximum degree of the graph plus 1. So the examples are Kp and Cp. So these are the two examples. So with this, what we have discussed in this session, we have discussed what is critical graph, what is K critical graph, and and we took some examples based on these concepts. Okay. So these are the reference books. Already I have mentioned the previous classes also. So with this, we conclude today's session. Thank you.